Imagine having an identical twin. You share the same birthday, the same DNA, the same childhood. But one day, your twin spends an entire year in space, while you remain here on Earth. When they finally return, something impossible has happened. Your twin is now younger than you, not by years, not by months, but by a real, measurable amount. It sounds like science fiction, but it isn't. Scientists have actually measured this phenomenon, and it's happening right now. Somewhere above Earth, astronauts are aging just a little more slowly than the rest of us. How is that even possible? How can two people born at exactly the same moment experience time differently? The answer will take us on a journey through one of the greatest discoveries in human history. A discovery that changed everything we thought we knew about time, space, and reality itself. This isn't just a theory. It actually happened. In 2015, NASA sent astronaut Scott Kelly on a mission that would change our understanding of the human body. He spent nearly 1 full year living aboard the International Space Station, orbiting Earth at incredible speed. Meanwhile, his identical twin brother, Mark Kelly, remained here on Earth. Because they shared almost identical DNA, NASA had a rare opportunity. Scientists compared the twins before, during, and after the mission. They studied their genes, their immune systems, their vision, and even the way their bodies adapted to life in space. But behind all those discoveries was one incredible fact. Scott Kelly had experienced time just a little differently. Not enough to notice with his own senses, but enough for scientists to measure. It was yet another confirmation that Einstein's extraordinary prediction was right. Time itself can change. So, how can moving through space actually slow down time? The answer begins with one of Einstein's most revolutionary ideas. Imagine a beam of light bouncing perfectly between two mirrors. Every time the light travels from one mirror to the other, the clock ticks once. Now imagine placing that clock inside a spacecraft, traveling at an incredible speed. To the astronaut inside the spacecraft, nothing seems different. The light still moves straight up and down. The clock keeps ticking normally. But to someone watching from Earth, the spacecraft is moving sideways. That means the light is no longer traveling in a straight line. Instead, it follows a much longer diagonal path. And because light always travels at exactly the same speed, covering that longer path takes more time. As a result, the clock appears to tick more slowly. This is called time dilation. The faster you travel through space, the slower you travel through time. It sounds impossible. But every astronaut aboard the International Space Station experiences this effect. But speed isn't the only thing that changes time. Gravity can do it too. In fact, gravity bends time in a completely different way. According to Einstein, gravity isn't just a force that pulls objects together. It's a curve in the fabric of space and time itself. Imagine placing a heavy bowling ball on a stretched rubber sheet. The sheet bends under its weight. Now roll a smaller ball across that sheet. Instead of moving in a straight line, it curves toward the heavier ball. That's a simple way to imagine how massive objects bend space-time. The stronger the gravity, the slower time passes. Even here on Earth, time doesn't flow at exactly the same rate everywhere. Someone standing on a mountain ages ever so slightly faster than someone standing at sea level, where Earth's gravity is a little stronger. The difference is tiny. Far too small to notice. But with modern atomic clocks, scientists can measure it. Time is literally flowing at different speeds across our planet. So, which effect wins? Speed or gravity? Astronauts aboard the International Space Station orbit Earth at nearly 28,000 kilometers per hour. At that incredible speed, Einstein's theory predicts that time should slow down for them. But there's another effect. The space station is also about 400 kilometers above Earth's surface. That means Earth's gravity is slightly weaker than it is down here, and weaker gravity causes time to pass a little faster. So, two different forces are acting on every astronaut at the same time. Their incredible speed slows time down, while the weaker gravity tries to speed it back up. After scientists calculate both effects, speed wins, which means astronauts aboard the International Space Station age just a tiny bit more slowly than people on Earth. The difference is incredibly small, but it's absolutely real. If you think that's incredible, it gets even stranger. Every time you use Google Maps, order a ride, or follow directions on your phone, you're relying on Einstein's theory of relativity. High above Earth, more than 30 GPS satellites orbit our planet. Each one carries an incredibly precise atomic clock, but those satellites are moving at thousands of kilometers per hour, and they're much farther away from Earth's gravity than we are. That means both speed and gravity are changing the way time passes for them, without correcting those tiny differences every single day. The clocks on the satellites would slowly drift out of sync with the clocks on Earth. Within just one day, your GPS could be wrong by several kilometers. You could end up navigating to the wrong street, or even the wrong city. The only reason GPS works so accurately is because scientists correct for time dilation every single day. Einstein imagined it more than a century ago. Today, millions of people unknowingly depend on it. Now imagine taking everything we've learned about time and pushing it to the absolute extreme. Instead of standing on Earth or orbiting aboard the International Space Station, imagine traveling to the edge of a black hole. A black hole is so massive, its gravity is unlike anything else in the universe. It doesn't just bend space, it bends time itself. The closer you get to a black hole, the more slowly time passes for you compared to someone far away. To you, everything feels completely normal. Your heart still beats, your watch still ticks. You can talk, walk, and think just as you always have. But for someone watching from a safe distance, your clock appears to slow down more and more. This incredible effect inspired one of the most unforgettable scenes in the movie Interstellar. On Miller's planet, which orbits extremely close to a massive black hole. 1 hour on the planet is portrayed as equal to about 7 years on Earth. The exact scenario in the movie depends on very specific conditions, but the underlying idea comes directly from Einstein's theory of general relativity. Now imagine spending just 1 year orbiting extremely close to a supermassive black hole under those extreme conditions. When you finally returned home, you might discover that decades, or even longer, had passed on Earth. The universe would have moved on without you, not because you traveled into the future, but because time itself flowed differently for you. Everything you've heard so far isn't just a fascinating theory. It's something engineers and scientists already have to consider. As humanity prepares to return to the moon, travel to Mars, and eventually journey even farther into deep space. Understanding how time behaves will become more important than ever. Future astronauts on years-long missions won't notice time slowing down in any meaningful way. The effect will still be incredibly small, but as our spacecraft become faster and our missions take us deeper into the universe, Einstein's discoveries will continue to shape how we navigate space. Perhaps one day, humanity will build ships capable of traveling at a significant fraction of the speed of light. If that happens, the people aboard those ships could return home to find that Earth has aged more than they have. Not because they entered a time machine, but because the universe has been working exactly as Einstein predicted all along. Time isn't broken. It simply doesn't flow the way our everyday lives make us believe. Time feels constant. Every second, every minute, every day. It seems to move at exactly the same pace, but the universe tells a different story. Time can stretch. It can slow down. And under the right conditions, two people can live through the same moment, yet experience different amounts of time. Astronauts have already shown us that this isn't science fiction. GPS satellites rely on it every single day, and somewhere in the darkness of the universe, black holes remind us that we've only begun to understand reality. Perhaps the greatest mystery isn't whether time exists, but whether we've truly understood what time really is. If you enjoyed exploring one of the universe's greatest mysteries, don't forget to like this video, subscribe to Space Chronicles, and turn on notifications, because the universe is filled with questions, and we're only getting started.